Okay, rewrite in radical form. So radical form is this. Remember, this is what we call a radical. If I say radical, that image should pop up in your head. Okay, so what you do is you take this number that's inside the parentheses, and we're going to put that inside. Well, it's all the first power, so I'm not going to do anything with the 1. But this 3 is the index, so it's the cube root of 3x, and that's your answer. Okay, so remember, if I say radical, that little house, little symbol is the thing that should pop in your head. Hopefully now throughout the rest of the semester and next year, if someone says radical, you at least know what they're talking about. That's one of my biggest things, like in co-taught when I was teaching. Someone's like, well, what's a radical? I'm like, we just went through the whole chapter. You should have asked me that in the beginning. Okay, that's a big thing, just knowing what it is when I talk about it. If you don't know, please stop me and I will explain it to you. Okay? All right. The homework answers are up here. If you want to check your answers, there were like only 1 or 2 people that actually finished it, so I'm not going to go over them. But if you have questions, you can come talk to me about it at the end of class, because you'll have time. All right, the notes. You want to go to day 6, and again, today is one of those days that if you're going into STEM, you're going to 098, whatever it is now, this is another day that is really important. Like, these notes look almost identical to the notes that you're going to take next year, too, in STEM, if you were. Okay, because I'm really close with a person that teaches that class, one of them. There's a couple teachers. And she gave me access to her notes so I can see what is done in that class. And this literally looks almost identical to one of the notes that they do. Okay, so this is definitely an important day if you're going to be taking that class next year. Okay, so the warm-up. We're just kind of doing the same thing we just did on the bell ringer, but so if you weren't here yesterday, this is kind of a summary of what we did. So that 9 goes inside this radical. We just need to figure out what that 2 and that 5 do. The index is the one that's on the bottom, so that 5 is going to go here, and that 2 is going to go here. Okay, it's just kind of like rewriting it. Well, what is 9 squared? 9 squared? Not the square root of 9, 9 squared. 81, very good. We're done. Okay? This one. Remember that this really means, what's really nice is when it's 1 over something, it just means that root. I'm just going to kind of go off to the side. This means square root. If you have something raised to the 1/2 power, that really means square root. Okay, so that is the square root of 3x then. Okay? You could put the 2 here if you really want to, but like I said yesterday, that if you look at your calculator, they don't put the 2 there. That's the only thing. But so I'm not going to put that there then. Okay, now let's go the reverse. So now we have the radical, we're going to exponential form. The 11 is your base. What number is on the top, the 4 or the 3? I heard it. Which one would go on the top, the 4 or the 3? The 4. And the 3 goes on the bottom. Okay, so that little index, this little piece right here is always on the bottom. Always. Never changes. Okay, same thing here. Now, remember, this whole thing is square rooted. So if the whole thing is square rooted, make sure that you put it in parentheses. Or you'd have to do it separately, put them both to the 1/2. So I'm going to have 1 over 2. Square root is 1/2 power, or you just know that this guy has a 2 there and it's 1 over 2. So let's just going back and forth between them. You did this last year, the radicals, where you remember you broke it down, you circled groups, pulled it out. That is one of the biggest topics in math across the board when you're in high school. So we're doing it again, but now I'm going to show you a different way, and you can kind of choose the way that you like. I've seen both ways work successfully. It really just depends on who you are. Some people are just good at doing it one way, and some people are good at doing it the other. If you're not organized, it's really hard to do that circle method that you probably learned last year. I'm not really sure. Everyone's different. If you came from co-taught, you probably weren't taught that circle method, but we'll see. Okay, so the very first thing I'm going to do is I'm going to list the 15 perfect squares. Okay, perfect squares are what that means is I can take the square root of it and I get a number back. Like the square root of 16 is 4. It's a perfect square root. So 1 squared is 1. What's 2 squared? 4. What's 3 squared? 9. Okay? Remember what squared means. Squared means you're multiplying itself twice. So 3 times 3 is 9. What about 4 squared? What's 4 times 4? 16, careful. What about 5 squared? 5 times 5. Okay, 6 squared. Good. And then 7 squared. Nice. And then 8 squared. 64. 9 squared. Good. We're going to start getting to harder ones. 10 squared. Easy. 11 squared. 121. 12 squared. Very good. 13 squared. Remember, 13 squared really means 13 times 13. Very good. And then 14 squared. I would never ask you to memorize this high up, but it is good to have it just down on paper. What is it? 196. And then 15 squared. I think it's 225. So you don't have to write these on the bottom. I just wrote that so that you knew where these numbers were coming from. Okay? And we're going to do the same thing, but now we're talking about perfect cubes. Remember, perfect cubes are like the cube root of 8 is 2. So 8 is a perfect cube. So I'm going to make a little note off to the side that what I mean by perfect cubes is that little cube root symbol. You can take the cube root of it and it work out. So 1 cubed is 1, because 1 times 1 times 1 is 1. Okay, what is 2 times 2 times 2? 8. What's 3 times 3 times 3, or 3 cubed? 3 times 3 is 9, and 9 times 3 is 27. You guys are killing it. Okay, and the rest you can just put in your calculator, or you can think about it in your head. 4 cubed, does anyone know what that is? 64. Ooh, that looks not like a 64. 64. Then I have 5 cubed. Again, you're just putting that in your calculator, or you're doing 5 times 125. 6 cubed, I can kind of just give you guys these ones, is 216. 7 cubed is 343. They're big numbers. I'm just writing them all out. You really don't need these high of ones, but it's kind of just nice to see it on paper. 9 cubed is 729. And 10 cubed is 1,000. Again, you really didn't need to write all this in the bottom, but I just wanted to show you where these big numbers were coming from. If you don't know how to put that in your calculator, I can show you just to confirm that you know how to put the cube in. The cube is coming from this little arrow symbol on your calculator. If I did 5 to the arrow like points it up, and then you just put the, not negative, just 3, you get the 125. So that's how you would put that in your calculator. Now, if you want to do the opposite, remember you press math, and look at, there's your cube root, that 4. And you can do the opposite. So if I put in 125, I should get back 5 based off of what we just said. And we do. Okay? Proved it to you there. All right. So now, this is what we, you've done this before, but I just want to make sure that we know how to do it a different way if you want to. Okay, so I'm going to go off to the side, and you need to have a calculator out, unless you're pretty good with your numbers. Okay, I'm going to have my calculator out. Now the goal is that you want to find the perfect square that goes into 20. What perfect square? So you have these options up here. Here's the perfect squares. Does 1 go in there? Does 4 go in there? Does 9 go in there? What number goes into 20 out of that list? 2 goes in there, but what perfect square goes into 20? Which one can be divided by 20? So 20 divided by 1 works. Does 20 divided by 4 work? Yeah, 20 divided by 4 is going to get me 5. So I'm going to break this down into the square root of 4 and the square root of 5. Right? Because 5 times 4 is 20. That's why we can do that. If you get stuck, here's what I want you to do. You take that 20 in your calculator and start dividing some numbers. You should know that 20 is not going to be divisible by like 16 or higher. But you can like do divided by 9 if you didn't know and be like, oh, that didn't work. 20 divided by 4 works. So you just divide until you get a perfect square that goes in there. Because what is the square root of 4? 2. So my final answer, when you break this down, I like to do this where I circle what comes out and I underline what stays in. My final answer will be 2 square root 5 is my final answer. It's called extracting roots. You're taking out like perfect squares from what you're given. Okay? Now, a lot of you, if you remember, I'm not going to have you write this down, but I'll show you what you were probably taught where you're like, oh, 2 and 10, 2 and 5, and you're like, oh, I'm going to circle, and I'm going to like take that out. That's great, but when you get to bigger numbers, it could be very unorganized and people get confused. And next year, if you're going to STEM, I'm telling you right now that that's how they're teaching it to you. And that's why I'm starting you guys to start doing it this way. But I worked with people on tutoring, and they did just fine with it. All you're doing is you're taking this 80, and you're going to start dividing it. Like, I don't have to divide by 81. I know that's not going to work, but I can just go down. 80 divided by 64, 80 divided by 49, until I find one that works. Okay, so let's go ahead and give it a try. I'm going to do 80. I'll start off with like 49 and see if that works. It doesn't. Okay? If it'll work for me. Hold on. There we go. That doesn't work. But I'm going to keep going. 80 divided by 36. Let's see if that works. Nope, it doesn't. Let's just keep going. 80 divided by 25. Still not going to work, but we're getting close. You see how the decimal is getting smaller. It's nice. 80 divided by 16. And look at that. We found it. 16 is the perfect square that goes into 80. So this breaks down into the square root of 16 times the square root of 5. And here's why I got 16 and 5. Again, the perfect square is 16, and I got back 5. Okay? Well, what is the square root of 16? It is 4. And then the 5 is going to stay inside. Okay? So the big thing here is that whatever's already on the outside, if you notice here in yellow, these two, you're going to have to multiply them once it comes out. So really what you're doing is 4 times 2, and I'll write that off to the side just so that you know on your notes when you go back. You're really doing 4 times 2 once it comes out. Well, what is 4 times 2? 8, and the 5 is still left inside. Okay, so when you are pulling out perfect squares, 16 was the highest perfect square that went into 80. And that's why we pulled it out. Do you have questions on that? Once you get used to it, it's pretty quick because all you're doing is you have your calculator out, you're doing 80 divided by those perfect squares. You can always make that list if you want it. Okay, let's do 116. Let's give it a try. So have your calculator out and start doing it. So 116, I'm not going to go higher than 116, so I'm not going to start at I'm not going to start at 121. I can start like a little bit lower. You should also know that 100 is probably not going to go in there either. So let's start with 81 and see. So divided by 81 doesn't work. Keep going. 116 divided by 64. Keep going. Nope, doesn't work. But you can see the decimal is getting smaller, right? So you're getting close is what that means. So I have 116 divided by 49. Nope, not going to work. 116 divided by 36. Still not working. Just keep going. You should probably know 25. It ends with a 5, so it's not going to work. So I'm going to do 9. 16 divided by 16. Still not working. 116 divided by 9. Still nothing. 116 divided by 4, and you'll notice it works. 4 and 29. Okay? So I have 4 and 29. So it goes pretty quick once you get used to it. So I have 4. Why is it doing that? Oh my gosh. Hold on. This computer is going to be sent in soon, so let's see if it works. Okay, so this is going to break down into the square root of 4 and the square root of 29. What is the square root of 4? 2. That comes out, this stays in. Because there is no square root of 29. If you put that in your calculator, it doesn't work. So your final answer is 2 square root 29. Do you have questions on that? Now, here's my biggest hint for this next one. If it ends with 25, what can you assume is probably going to go into there? The 5. Okay, and the perfect square of 5 is 25, because 5 squared is 25. So let's try that. So it's like a big hint for you. If it ends in 25, it's most likely going to be 25, but let's try it to make sure. I have 125 divided by my perfect square of 25, which is 5. Okay, so that's what I'm going to do. I'm going to write this out as the square root of 25 times the square root of 5. What is the square root of 25? 5. That comes out, that stays in. What you do is you do 5 times negative 3. I'm just going to write that out for you for your notes. You're doing 5 times negative 3, which is what? Negative 15. And then square root 5 is still left inside. Do you remember doing these types of problems in the past? You've done them. Yeah, you do. You've done it. You just haven't done it this way. Okay, this is what you probably would have done last year. You probably broke it down into 5 and 25, and then you're like, okay, I'm going to keep going like this. And then you circle, come out. That's usually the way that people get taught at the different levels, okay? That's great. If you want to do that, I would never tell you not to, okay? So if you feel more comfortable doing it that way, please do it. I'm just telling you that when you get to more advanced classes, like next year if you're going to STEM, you won't see this. You will see this, okay? But even in STEM, they do encourage you, if you learned it that way and you like it better, they don't care as long as you get the right answer, okay? But I just know it's going to be taught this way next year, again. So we're going to kind of get your feet wet with that. And you'll see when we get to bigger problems, like it leads to some like really weird organizations if you can't break it down correctly. Okay, so let's do it again. Now we're going to do cubes. Is that a question? Okay, perfect cubes. We're doing the same thing, but now we're talking about that list right there, that second list. So let's start doing that. 81. You're just going to take 81 and start dividing some numbers here. So let me get my list out. Again, you probably don't need to do 125. That's too high. So 81 divided by, let's see, 27. And look at that. It worked. Okay, it's pretty quick once you do that. Like once you get used to this, it's pretty fast. Because again, if you had to break down 81, I'll show you that method too, it would take you longer. So I have the cube root of 27 times the cube root of 3. And how did I get that? That 27 and that 3. What is the cube root of 27? 3. So 3 comes out. This cube root of 3 stays in. And we're done. We'll just rewrite it. 3 cube root 3. Final answer. Now, if you're someone that's like, I don't like that, I like the way I was taught last year, I'll show you how you do that. Don't write this down unless you really want to. If you were to do it, you would have to be like, okay, usually 9 and 9 comes to mind when people do this. Okay? Then you would have 3 and 3, and 3 and 3. And then you're like, okay, I have a group of 3 and 1 stays in. And then that's where that 3 comes in and that 3 comes in. So if you like that method better from last year, please do it. If you're going to STEM, please don't. Because again, you're just not going to be taught that way, and I wouldn't want you to get confused. Okay? Try this. See if you like this better. And if you don't, I can always reteach it to you personally how to do it the other method. It just, again, sometimes can get unorganized when you do it that way. All right, let's do it again. This one should be easy. 16. Look at your list. What? Yeah, 8. This guy right here is the one that goes into 16. Okay, so I have the cube root of 8 times the cube root of what number gets me 16? 2. Are we okay there? Well, what is the cube root of 8? Careful. 2. Remember, cube root 8, 2 times 2 is 4, 4 times 2 is 8. If you get stuck on that, you can go to your calculator and just put in that cube root symbol. So this comes out, this stays in. Here we go. We have to multiply this to whatever's on the outside. So really you're doing 2 times 2 here, which gets me what? 4. And what's left is the cube root of 2. Make sure you have this little index of 3 because that's super important. The cube root of 2 is different than the square root of 2. That's why we got to make sure it's in there. Okay. So this one, just being a math person, like if it ends with a 0 or 5, it's probably going to be that 5 that goes in there. So the 5 cubed one, if I look back up, is the 125. So whenever you end with like a 0 or a 5, always check that and see. So let's see if 125 does go into 250. So let's see, 250 divided by 125. Look at that, gets us 2. So I have the cube root of 125 times the cube root of 2 here. So I have the cube root of 125 times the cube root of 2. What is the cube root of 125 based off our list or based off your calculator? It's 5. See that, how I circled it? It's the 5 cubed. So the answer, that 5 is going to come out, and that cube root 2 is going to stay in. So 5 cube root 2. Radicals, factoring, solving. The 3 things that in high school you should walk away with. This is a big one. Radicals, this lesson won't go away even if you're going to JJC or even going to a college. Okay? Maybe not a trade school, but finished? Thanks. Have a good one. All right, let's do it again. 24 is a pretty easy number, right? What perfect cube goes into 24? You can kind of just look here. Here's my list. Take a look down here. What perfect cube, 1, 8, 27, 64, goes into 24? 8, right? 8 times 3 gets me 24. So this is going to be the cube root of 8 times the cube root of 3, because 8 times 3 is 24. Well, the cube root of 8 is what number? 2. And then this guy stays in. Here we go. 2 times 3 gets me 6, and then that cube root 3 stays inside. Once you get used to this, guys, it's not awful. And breaking that habit of doing the factor trees is definitely difficult to do. And after talking to your Math 2 teachers, they're going to start teaching it this way at the Math 2 level now, because they know that in the future, that's the way it's going to be taught in Math 3 and in 098. Okay? Go ahead and flip when you're ready so you can move on. Now we're doing the same exact thing, just more practice, but now we're going to throw in some letters. Me personally, I think letters are easier than numbers in these types of problems. Okay? And I'll show you why. Let's take a look here. All right, so rewrite by extracting all the roots. That just means like simplify it as far as you can. So, but this is one's really nice. What is the square root of 16? Do we know that? It's 4. So that's coming out. Like there's nothing left inside. Now I'm going to show you 2 ways to do this x one. What is my index? What's secretly here? A 2. So I'm going to show you this. What is 6 divided by 2? 3. That means you have 3 x's that come on the outside of your radical. So my final answer would be 4x cubed. And I'm done. And here's why. This is like the visual now. So if you like visuals, you're more than welcome to write these out for yourself. If I write out 6 x's, because that's how many I have, right? I have 6 x's. If I circle groups of 2, look, I have 1, 2, 3. Okay? So that's a good visual for you if you would rather do it visually instead of doing it algebraically. Just depends on who you are. Sometimes they're easy to work with, sometimes they're a little bit harder. Let's take a look at this next one. What perfect square goes into 8? What perfect square divides into 8? 4. Good. So I have the square root of 4 and the square root of 2. Well, we know the square root of 4 is what? 2. Very good. That guy stays in. So let's take care of that number right away. Remember, it's 2 times that negative, which is negative 2. And then that radical, we'll do that in a second because that's left over. Now, some people get confused on this part just because it's not an even number and our index is even. But there's a couple ways to do this. So, how many times does 2 divide into 3? Okay, because that's our index. Here's a good way to do that. You can use your calculator even. You can do 3 divided by the index of 2. And notice that only one's going to come out, right? One group. But now we have to figure out how many is going to be left over. So again, two ways to do this. I know there's going to be one V that comes out, right? Because that's what my calculator told me. It said 1.5. 1 is the only thing that goes in there. But how many is left? Think about that. If I took out one group of 2, how many would be left if I started with 3? That's a good question. So if I break this down for you like this, and I circle my one group, how many's left? 1. So I have square root of V left over. Oop, I left something out. My underlined piece, my 2. Okay. So there's 2 ways to think about this. How many times does 2 go into 3? 1 time with 1 left over. Or just write these out for yourself. Either way, some people can do it in their head, or some people like to write out. It just depends on who you are. Let's do it again. Let's keep practicing. The cube root of 343. I'm pretty sure that that's a perfect cube if we go back to our list. Let's take a look. There it is, right here. So the perfect cube of 343 is 7. But if you didn't know that off the top of your head, you can use your calculator. And I'll show you again how to use your calculator for this. You press math, that math button right there. If you see number 4, it has that cube root symbol. And you can put in 343, and you should get back 7. Okay, so here I have, this is gonna be 7. We know that for a fact. But now let's talk about these variables. This A is gonna be pretty easy. When it divides into it, it's pretty easy. What is 15? I'll write it out. 15 divided by 3. 15 divided by 3? 5. So that means there are 5 A's that come outside this radical. Okay, so I'm going to start writing it out. I have 7, and then I have 5 A's that come out. That's what that looks like. Now the next one's not as easy because it's a 10, and 10 doesn't be divided by 3 here. So if you ask yourself 10 divided by 3, do that in your calculator. Let's see. How many times does 3 go into 10? Let's see. It says 3 times, right? 3. So that 3 is going to come outside. And let's talk about what that means. So in purple, I have B to the 3. But let's figure out what's left inside, because there will be something left inside. For those that have that math ability, whatever you pull out, I pulled out 3. 3 times 3 is 9. So I took a total of 9 B's from 10. How many is left? 1. And I will show you that visually for those that would like it to be visual. That is your answer, but let me show it to you for those that want it. If you like the other way, then don't even look right now. I'm going to write this out into groups of 3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So look, I have 1, 2, 3, 1, 2, 3, and 1 left inside. That's really what you're doing when you do that. 3 times 3 is 9, and I started with 10. That's why there was only 1 left over. Once you get the swing of that, I think that's the easier way to do it. Then, because what if I gave you like B to the 100? You have to like write out 100 B's, and that's craziness. Okay, let's keep trying it. 63. We need the perfect square that goes into 63. Does anyone know a perfect square that goes into 63? 8 isn't a perfect square. So like, I can't take the square root of 8, but I understand where you're getting that from. What perfect square goes into 63? You can go back to your list. Here's my perfect squares. So I'm going to be looking somewhere around here because 63 is bigger than all the rest of those. So which one of those numbers goes into 63? 9. Okay? Again, if you got stuck, you're like, I don't know what goes in there, use your calculator. Just start doing it. 63 divided by 36 doesn't work. 63 divided by 16 doesn't work. You just keep going until you find one. So here I have 63 divided by 9, which gets me what? The square root of 9 and the square root of 7. Very good. Because 9 times 7 gets me 63. And this is why I told you that extra math is super important. Those quick math skills are huge. Well, what is the square root of 9? 3. That comes out, this stays in. So I'm just going to start writing it out for myself. 3, and I know that 7's going to stay inside. I'm going to leave some space for my letters. Let's ask ourselves. Remember, there's a secret 2 here. How many times can you divide? Yeah, 4 divided by 2 is equal to 2. So my h is nice. It's pretty. Okay, there's no left over. So I have h squared in red. Because 4 divided by 2 is 2. Now in green, what's 6? I'm going to write it out. 6 divided by 2. 3. So I have j to the 3rd power, and that's my final answer. If it comes out as a decimal, then there's going to be something left inside, and we have to figure out what that is. Okay? This next one's pretty nice because the 25 is a perfect square. What is the square root of 25? 5. That comes outside. He's hanging out here. He's chilling. Okay, let's talk about this. 2 divides into 2 how many times? 1. So there's only one b that's on the outside of the radical. So b, if you want to put to the 1 power, you can, or you can just put b. Let's do it again in purple. What's 8 divided by 2? 4. So I have 4 b's coming out. I'm sorry, that's supposed to be an a, isn't it? You gotta tell me those things. A, and then the purple one was b to the 4th. Let's talk about this green 10 here. 10 goes into 2 how many times? 5. So I have c to the 5. There was nothing left over on all of them. 25 was a perfect square. A square was perfect square. Everything else was perfect. Again, if you would have gotten the decimal on your calculator or in your head, you would have had to do some more work here. We're almost there. Just take a breather. Getting close. I'm not going to do F just because I'm not going to ask you about the 4th root. Okay? If we have time in the future, we'll go back to the 4th roots. But let's talk about these ones. They're actually not bad. They look weird and like hard, but they're really easy actually. Because you ask yourself, how many times does 3 divide into 9? What is 9 divided by 3? 3. So your final answer is x plus 3, all in green here to the 3rd power. You're done. All you're doing is you're taking that exponent, you're dividing it by the index. You're taking the exponent of 9, dividing it by that index of 3. Last round here. How many times does 2 divide into 2? Not multiply, divide. Did you say 4 or 1? Oh, I thought you said 4. I was like, what? Okay, good. It is 1. So your answer would be x plus 3 all the 1st power, or you could just leave it. So you could put the 1 there, or you can leave it out, and you'll be done there. Okay? I know that it's kind of challenging, and this stuff is not easy. It never has been. That's why radicals is always brought up, because it is a difficult topic. Radicals, factoring, and solving, the 3 things that you walk out of high school with, hopefully going into college or UC. Because your basic skills class that you will be required to take, you have to take a required math class in college, no matter what level you go into. You're going to be asked these questions, so you might as well learn it now and not stress out as much in college is my recommendation. Okay? Take your time on these, please. There's only 8, okay, so that you can work on it. There is a review. I want you to try this. Okay, I want you to get some practice reviewing because the test will be coming up soon. Not really soon, but you have a good 16 minutes to start working on this. Please ask me questions. I have the key already posted, detailed. I'm gonna put that in right now. Yeah, sorry, I realized that this morning actually. It's been kind of crazy. I'm not even gonna give this to you unless you want to try it. Okay. Oh my God, that was your phone. What? Which calculator is expensive too? But I thought it was your phone. It sounded like that. We're all good. Everyone get one of these? Okay. The key. I'm not. The key is right here. I color coded it and everything for you so you can